So we're doing another Rosen question, Discrete Mathematics and its Applications, 7th edition, chapter 5.1, question 7. We want to prove by induction that 3 plus 3 times 5 plus 3 times 5 squared plus ... plus 3 times 5 to the n is equal to 3 times 5 to the n plus 1 minus 1 divided by 4. Where n is going to range over non-negative integers, meaning that n starts at 0. We can think of this as a set of the natural numbers in 0. Some people include 0 in the naturals, so I wrote it like that just in case you don't. So the proof is by induction. And induction requires us first to show that the base case holds. The base case here, again, starts at 0. So we could think of this as being the first term on the left-hand side, which is 3, or the fact that we have 3 times 5 to the n, we can replace that n with 0, and anything raised to 0 is 1, so that's 3. So you can see how the first term and that 3 times 5 to the n are the same. So the left-hand side is equal to 3. So we want to show the right-hand side is also equal to 3. Now the right-hand side was 3 times 5 to the n plus 1 minus 1 divided by 4. So it's 3, 5, 0 plus 1 minus 1 divided by 4. That is equal to 3 times 5 minus 1 divided by 4, which is 3 times 4 divided by 4, which is 3. So the right-hand side equals 3. So the left-hand side and the right-hand side are the same. So the base case holds. So now I can proceed to the inductive step. The inductive step, I can't say inductive step. First thing we want to do is establish an induction hypothesis, which is always the statement replaced with integer k. So we're going to assume that 3 plus 3 times 5 plus 3 times 5 squared plus ... plus 3 times 5 to the n is equal to, oh, I said k, but I put n, so let's get that out of there, is equal to 3 times 5 to the k plus 1 minus 1 divided by 4. And again, this is for some k greater than or equal to 0. So this is what we're assuming to be true. And induction works because we're assuming all cases of integers to k is true, and then we're going to show the k plus 1 case is true, or the next term, so to speak. So we want to show that the k plus 1 case holds. So what's the k plus 1? I'm going to write down the left-hand side first, and I'm going to add the next term, or the k plus 1 term. And then that's 3 times 5 to the k plus 3 times 5 to the k plus 1. And hopefully this is going to be equal. That's why I'm putting the question mark. It's not equal. We're not assuming this is equal. This is what we want to show. This is a k. This is equal to, hopefully, 5 k plus 1 minus 1 divided by 4. Now the right-hand side, I just replaced k with k plus 1. That's the only difference here. Let me write this as 3, 5, k plus 2 minus 1 divided by 4. I'm just adding 1 and 1, so we get a better sense of this. All right, so with induction proofs with equalities, we generally want to show that the right-hand side and left-hand side are the same. We can do this via algebra. Just pick a side. In most cases, especially within Rosen and discrete mathematics, is to take the left-hand side or the summation side and see if we can manipulate it algebraically to equal the right-hand side. So we're going to write the left-hand side again. 3 times plus, I keep on to say times, 3 times 5 squared plus dot, 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 plus 3 times 5 to the k plus 3 times 5 to the k plus 1. So I'm going to manipulate this left-hand side, make it look like the right-hand side, and we'll be done with our proof. So the first thing I'm going to do, which might seem a little tedious as far as writing, but I am just grouping the first k terms, and I'm going to leave the last term over here just by itself. The reason is because this is the induction hypothesis. This is the thing that we assume true above. Where is it? Here. So we're saying that the summation to k is equal to that right-hand side. So I'm just going to replace that with 5k plus 1 minus 1 divided by 4. And I'm going to bring down this term. So that's 3 plus 5 to the k plus 1. All right, so again, this is by induction hypothesis, or IH. In induction proofs, you're always going to use your induction hypothesis. If you complete a proof and you haven't used your induction hypothesis, odds are that you've made some assumption along the way that you shouldn't have, or something else went horribly wrong. All right, so now if we just look at the algebra, I want to add these two terms. So adding these two terms requires us to have a common denominator. So that means I have to multiply the top and bottom of the right-hand term. This is not 3 plus 5. This should be 3 times 5. My fault. Notation. So we want to have 3 times 5 to the k plus 1. So multiply the top and bottom by 4. And then we have 3, 5k plus 1 minus 1 plus 4 times 3 times 5k plus 1 divided by 4. All right, so now we start collecting stuff, if we can, factoring out based upon maybe some stuff that we need. You see both terms have a 3 in it. So let's bring that 3 out, and then we can bring this denominator out. And then we are left with 5k plus 1 minus 1 plus 4 times 5k plus 1. So I'm being a little liberal with my parentheses, but it helps me stay on track. I'm writing real big as well. All right, so this is essentially 5k plus 1 minus 1 plus 4 times that, 5 plus 5k plus 1. So I'm going to group it a little bit differently so that we can see that we can factor two terms. So I'm grouping the 5k plus 1 and the 4 times 5k plus 1, and I'm going to leave this negative 1 out here. Now, you should notice that essentially we can group these first two terms separately. That grouping allows us to factor out the 5k plus 1. And when we do that, here we're left with a 1, and then here we're left with a 4. And that's minus 1. So what is 4 plus 1? Well, it's 5. So let's write that. So we have 5k plus 1 times 5 minus 1. Oh, wait, 1. But we can think of that as being 5 to the 1. Now remember, your exponent rule is that if I have the same bases and they're multiplied, that means I can take the base and then add the exponents. So 5k plus 1 becomes 5k plus 2. So this is equal to 3/4 times 5k plus 2 minus 1. We'll run this through so it looks a little bit better. And by better, I mean more like our original problem. All right, so that is 3 times 5k plus 2 minus 1 divided by 4. And again, if we look back to what we wanted to get, the question mark is exactly what we wanted. So we have just shown that the left-hand side is equal to the right-hand side. Therefore, QED or box, we are done.